You can mention the doubt if you have in any of the question. Question one, any doubt? Question one, any doubt? Question one, part B. Okay. Question one, part B. Two coherent waves X and Y meet at a point and superimpose. The phase difference between the two waves at this point is 180. So if the phase difference is 180 means it's a destructive interference. Because if the phase difference is 360 or 2 pi radian, then it will be a constructive interference. The wave X has an amplitude of 1.2 centimeter and intensity I. The wave Y has an amplitude 3.6. Calculate in terms of I the resultant intensity at the meeting point. So what is the relation between the intensity and the amplitude? Intensity is directly proportional to amplitude square. If we double the amplitude, intensity will be 4 times. If we triple the amplitude, intensity will be 9 times because it is proportionality square relation. So we can say intensity is directly proportional to amplitude square. Whenever two quantities are directly proportional, when two quantities are directly proportional, their ratio is constant. Means we can also say that intensity divided by amplitude square will be K, constant. So in short, we can say, like, as we know, intensity is directly proportional to amplitude square. So intensity divided by amplitude square will be equals to K, constant. So for a wave X, like example, intensity of a X, we call I, divided by amplitude. What is the amplitude of X? Amplitude of X is 1.2. So we call 1.2 square. That will be equals to K. Same thing, intensity of the Y, we don't know, we call IY. And what is the amplitude of the Y? The amplitude of the Y is 3.6, so we can say 3.6 square. And that will also be equals to K. As the two waves, we know the intensity is directly proportional to amplitude square. Now, in the question, we need the resultant, in terms of I, the resultant intensity. What will be the resultant intensity? As I mentioned that the two waves are 180 out of phase. So what they will do, they will try to cancel out the effect of each other. Because whenever the phase difference or the angle difference is 180, the two waves try to cancel out each other at that point. So means if we want to write an equation for the resultant intensity, so what will the resultant intensity? So the resultant intensity example IR will be equals to what? What is the resultant amplitude? The resultant amplitude will be the difference of the two. If the phase difference here was given 360, then the resultant amplitude will be the sum of the two. So what is the resultant amplitude here? It will be 3.6 minus 1.2 whole square. And that will also be equals to K. Now we can compare, because we have this factor, like we can compare this first equation with the resultant equation. So we can compare these two values. We can say I over 1.2 square is equals to IR divided by 3.6 minus 1.2 square. Because we need the resultant. Just cross multiply. So that is equals to 2.4. So this will be 2.4 square into I divided by 1.2 square. That is equals to the resultant. What's the answer for this? 2.4 square divided by 1.2 square. So the resultant intensity is equals to 4. 4I. Because in terms of I, we need, so we have to write 4I. But if they ask the same question, they ask what is the intensity of y, then we will compare this equation with this one. And if the phase difference was 360, then instead of finding the resultant by subtraction, we will add the two values. Is it clear? Should I repeat? So when the two waves meet at these points, they have a 180 out of phase. So when they are 180 out of phase, it means to get the resultant velocity intensity, it will be the difference of the two. Because y is having a greater intensity, that's why we did y minus x. In part C1, monochromatic light is incident on a diffraction grating. Describe the diffraction of the light waves as they passes through a grating. So what actually happened? What happened in a diffraction? Diffraction is the spreading of the wave when it passes through a gap or a slit. We call that as a diffraction. So as wave is passing through the slit, it is spread out and we call that as diffraction. And it is maximum when the wavelength is approximately equals to the gap size. A parallel beam of a light consists of two wavelengths, 540 nanometers and 630 nanometers. The light incident normally on the diffraction grating. The third order diffraction maxima are produced for each of the two wavelengths. No higher order are produced by either. That's a maximum we got, like third order image we got. Determine the smallest possible line spacing, D, for the diffraction grating. So we want to work out the value for D, and it's about the maxima. Because in the question, we need this smallest possible spacing, the smallest possible spacing. So the which wavelength, two wavelengths are there, but which wavelength we should take, because longer wavelength diffract more. Like we want a maximum diffraction. So if we want to determine the smallest line spacing, so which wavelength we should take? We have 540 is given to us and we have 630 nanometer. So we'll take 630 nanometer. So a parallel light beam which consists of 540 nanometer and 630 nanometer. And the light is incident normally, like example, so this is a grating element. And the light is incident. It causes images. There is a maxima, central maxima, then there will be minima, then maxima, then minima, and so on, minima, maxima. So maximum we got third order. Like example, this is n is equals to 0, 1, then 2 will be there and 3. Same thing, n is equals to 1, 2, and 3. That's the maximum we got. No higher orders are produced by either of these wavelengths. So we want to determine the smallest possible line spacing, D. We want to determine this D. So if we want a smallest, like if a D is smaller, it means we are talking about like smallest one, we have to take a longest wavelength. Why we have to take a longest wavelength? Because when narrow slit size and a longer wavelength, it diffract more. So we don't have to take difference of these two wavelengths. We have to take only single wavelength, that is 630 nanometer. Because that will diffract more. When it diffract more, we'll know the smallest possible value for the line spacing, the D. So we use a formula that D sine theta is equals to n lambda. So the formula is D sine theta is equals to n lambda. If we want a maximum diffraction, because the relation here, we want theta to be maximum. If we want theta to be maximum, what is the relation? So sine theta is n lambda over D. N is constant here, which is 3. So the wavelength should be, if we want the maxima, so lambda should be maximum and D should be the smallest one. That's why we are taking the longest wavelength. So d sine theta is equals to n lambda if we need d. What about the maximum possible angle for a grating element? We always take that as 90 degrees, as sine 90 is maximum. So this will be 90. N is the order of image. It's a third order image and it's a maxima. So it will be 630 into 10 to the power minus 9. So if we need d, so it will be equals to 3 times 630 exponent 9 divided by 1, which is the same answer. So that is 1.9 into 10 to the power minus 6 and meter. Is it clear? The smallest possible line spacing. Because we want a maximum diffraction. When we want a maximum diffraction, so the line spacing should be minimum. That's why we took the longest wavelength. The beam of a light in C2 is replaced by a beam of a blue incident light. So before we were using a monochromatic light, we were using a monochromatic light 5 because the range is there from 400 nanometers to 700 nanometer. 700 nanometer is a red and 400 nanometer is a violet. So the beam of a light in C2 is replaced by a beam of a blue light on the same diffraction grating. State and explain whether the third order diffraction maxima is produced for this blue light. So if you compare the blue light with this wavelength, like when we were using 630 nanometer, the longest wavelength, it was producing third order maxima. Like this is the central maxima where n is equals to 0. Then n is equals to 1, n is equals to 2, and n is equals to 3. And the wavelength which we were using 540 nanometer. That is one of the wavelength. And we use another wavelength which is 630 nanometer because longer wavelength diffract more. So even with 630 nanometer, it was producing. Even with 630 nanometer, it was producing a third order image. Now the question is, we are using a blue light. When we compare the blue light will have a shorter wavelength than this 630. So blue light, when it will have a shorter wavelength, then shorter wavelength diffract less. So if it diffract less, so definitely for a blue light, it might produce more than 3. Because the blue light, as it is having a shorter wavelength, it will diffract less. So this will be n is equals to 1 for blue, n is equals to 2, and n is equals to 3. So the answer here, the structure of an answer will mention the blue light is having a shorter wavelength diffract less. So shorter wavelengths are there, shorter wavelength diffract less. As it diffract less, so as a result, we'll get a more order of image. Even n is equals to 3 is possible. So n is third order diffraction maxima will produce, or it might produce more than 3, but yes, there will be 3 order images. Is it clear? Shorter wavelength diffract less, longer wavelength diffract. With a shorter wavelength, we'll have more order of the image because you have the formula d sine theta is equals to n lambda. So what is the relation if d sine theta is constant, because angle is 90 and spacing is constant, what is the relation between n and wavelength? They are inverse. So if you decrease the wavelength, what will happen to the value of the n? The value of n will increase. So that's why shorter wavelength produce more diffraction patterns, like more images as compared to the value of n will be higher. When we say diffract mode, what is the meaning of the term diffract mode? When the wave is passing through the slit. So diffract mode means spacing between the maximas and the minimas will be more. Less order images will be there. This is more diffraction. Like here, n is equals to 0, n is equals to 1, and n is equals to 2. And here, n is equals to 1 and n is equals to 2. Red is having a longer wavelength, so red will diffract more. But if I use a blue light, the blue light will diffract less compared to, because blue light is having a shorter wavelength, so shorter wavelength diffract less. So the order of the image depending on value of n. Is it clear? The concept of diffraction? When the wavelength is approximately equals to the gap size, or it is greater than the gap size, then we'll have a maximum diffraction. When the wavelength is less than the gap size, then we'll have a minimum diffraction. Minimum spreading of the wave. And the diffraction, we have the formula that d sine theta is equals to n lambda. For a maximum diffraction, the theta is 90. So sine 90 is 1. So the relation is d is equals to n lambda. If we have a constant d, if we increase the wavelength, then the order of image will decrease. And if we have a constant value for d, if we reduce the wavelength, then the number of or order of image will increase. N is the order of image. Like n is equals to 1, n is equals to 2, n is equals to 3, and so on. So diffraction is maximum if the wavelength is greater than or equals to the gap size, not less than. When the wavelength is less, then minimum diffraction. In the question, because see, they ask about the beam of a light is replaced by a blue incident. So state and explain whether the third order diffraction maxima is produced in this blue. So how we know, like as you can see, d sine theta is equals to n lambda. We did not change the angle, we did not change the d. This is constant. So means this product should also be constant. For a blue, it's having a shorter wavelength. So if the wavelength is shorter, the n will be more. The order of the image. So that's why if this is producing, these longer wavelengths are producing 3, definitely shorter wavelength will also produce 3. Question 2, any doubt? Question 2. Part B and C. The battery with the EMF of 5.6 with the internal resistance R is connected to 2 external resistors as shown. The reading on the voltmeter is 4.8. So the external voltage is 4.8. It means if this is reading 4.8 volts, these two parallel will also have 4.8. And how much voltage will drop internally? If this is 5.6 and the resultant is 4.8, so remaining voltage of 0. Because we want a 4.8, so this will be 0.8 volts here. 5.6 minus 0.8, so we got 4.8 volts. The reading on the voltmeter is 4.8. Calculate the combined resistance of the two resistors in parallel. If the two resistors are connected in parallel, you can use a formula product divided by sum, or you can also use a formula 1 over RT equals 1 over R1 plus 1 over R2. When two are there in parallel, it's a product divided by sum. So 18 into 90 divided by 18 plus 90. What is the result here? So this is 15 ohm. The 15 ohm is the resistance of this, the current in the battery. If we need current in the battery, so how we know the current in the battery? So we know this is 15. Like we will just find the current in this branch, which the total resistance is 15 ohm. So we can find the current. We know the voltage here is 4.8. So we'll use the formula V equals IR. V is the voltage. We will use 4.8 because across this parallel combination, I is the current which we don't know and R is the resistance 15. So it will be 4.8 divided by 15. What is the value for I? So we got 0.32 ampere. So 0.32 ampere is the current which will flow through this. Why didn't we use 5.6? Because why we did not use 5.6? 5.6 is the EMF. That is the voltage of the supply, but some of the loss voltage is there, which is loss 0.8. So how much voltage we get output? We got output voltage of 4.8. And that same output voltage is across these two parallel, 4.8. So this, we know the resistance of this section and we know the voltage of this section. That's why we use a formula V equals IR and substituted the value. The 0.8 is a loss voltage. We don't receive that voltage. That is loss within the battery because of its internal resistance. So we always get a net voltage. We don't receive what is loss. We receive the result. That's why 5.6 minus 0.8, which is 4.8. So 4.8 is a total voltage output which is given out by this cell. 0.8 is a loss voltage within the internal resistance. So when we work out the current here, we got the value 0.32 ampere. So it means the same current is coming from the battery 0.32 ampere and the same current is returning to the internal resistance through internal resistance 0.32 ampere. So the current will divide into branches here and then the same will combine and return back. So if we work out the current in this parallel combination, that is the same current which is coming out from the battery. Show that the internal resistance is 2.5. How we show that the internal resistance is 2.5? As we already worked out that the current will be 0.32 ampere. We know the voltage here, how much voltage is dropped here because total output is 4.8. So this is 5.6. So this will be 0.8 volts. So if we need the resistance, it will be a ratio between voltage and current. 0.8 is a voltage across the internal resistance and 0.32 is a current which is passing through the internal resistance. What's the answer here? 2.5. So we get the value for internal resistance, that is 2.5 ohm. If you use a formula EMF is V plus IR, you will get the same result. If you use EMF is equals to V plus IR, EMF is 5.6, V is 4.8, I is a current which is 0.32 and R. When you do 5.6 minus 4.8 divided by 0.32, you will get the same answer as what I got. Because I just directly use the voltage here. By subtracting, you can use a formula and show that. Same result, it will not make difference. Determine the ratio of the power dissipated in internal and total power produced by the battery. So the power dissipation formula is always I square R. So power dissipation, it will be I square R That is I is the current and R is the resistance. And the output power dissipated, you can take a different formula as well. That's fine. If you want to use a different formula, it will not make difference because, and what is the total power of produced by the battery? Because for a battery, we know in the question, we know the EMF of the battery, it is 5.6. And we know the current which is coming out from the battery, that is 0.32 ampere. So for power produced by the battery, I can use a formula VI. So I can substitute the value and then I can substitute the values and then work out the ratio here, or I can just cancel out I with here, then it will become IR over V. So 0.32 times the internal resistance, which is 2.5 divided by the voltage 5.6. What's the final ratio? 0.14 or 0.14. Or you can write in a fraction as well. Yeah, 1 is to 7, or you can write in fraction, or you can write the number here that the ratio between, you can write 0.14 as a decimal, or you can write 1 is to 7. Both ways are correct. The battery in B is now connected. The battery in B is now connected to a battery of EMF 7.2 volts. The internal resistance is 3.5. The new circuit is shown to determine the current in the circuit. So you can use the Kirchhoff's law to work out this, or you can use a formula V is equals to IR, where V will be the total voltage, R will be the total resistance, and I will be the current. Both ways it will work. This battery want to transfer energy in this direction, the 5.6, and the 7.2 is transferring energy in other direction. So it means whenever they want like two batteries transferring energy in opposite direction, to work out the resultant EMF, what we do, we subtract them. And we can also use the Kirchhoff's second law, the total EMF. Like if we consider the current I is flowing, the current I will flow in the circuit because this is a high voltage 7.2. So the current direction will be in this way. So if the current I is flowing, we can use a Kirchhoff's second law. The total EMF will be equals to total potential difference. So what is the total EMF? That will be 7.2 minus 5.6 because in opposite direction equals to total potential difference. The total potential difference, it will be equals to this 2.5 I plus, because voltage is a product of resistance and current, time 3.5 I. Now we can simplify this. So 7.2 minus 5.6, that is 1.6. And this is equals to 6I. So we divide 1.6 divided by 6. What's the answer? 0.27. So you got 0.27 ampere. This is one way of doing the question. You can use another method as well. What is another method? You can use a formula V is equals to IR. The total EMF will be equals to I times I. So that will be 7.2 minus 5.6. I is the current in the circuit and R is the total resistance 2.5 plus 3.5. Why we add them? Because these two resistors are connected in series. So when you will solve, you will get the same result. So this was a structure pop quiz.